Good morning, everybody. Today we are discussing the next topic of the stereochemistry. Yesterday we have discussed the different representation of an organic molecule in two-dimension method. So we have four method: the Fisher projection and Newman projection, Sawhorse, and flying wedge representation. This is the representation of an ethane molecule in the different representation. This is the representation of the same molecule ethane. From that we can understand that the these representation are interconvertible. We can easily convert the Newman projection to Fisher projection, and Fisher projection to Newman, and Newman to Sawhorse, and flying wedge any other. So these are the importance of the representation. Now we are moving into another title, that is the dihedral angle. Dihedral angle, I have represented one molecule as ACCB. See here we can see the three sigma bond here. One is AC bond, other is CC sigma bond, the other one is the CB sigma bond. And if you are representing this 3 sigma bond in a plane, we can see the two different plane here. So first plane represent ACC bond, and this plane is known as ACC plane. And the next bond, that is CCB bond, are represented is in another plane, that is CCB plane. So the angle between these two planes is known as the dihedral angle. Then I have represented the same molecule in another fashion in the three-dimensional space. It is represented in the bottom of the slide. So from here we can see that A and B are the same side of the CC sigma bond. So if you are representing the same molecule in a Fisher projection, the Newman projection formula, we can see that the atom B is just behind, atom A is just behind the B. So the angle between the ACCB is 0 degree. And so here the dihedral angle is 0 degree. And I have also shown another different fashion of the same molecule ACCB. And here CA and CB bond are just opposite each other. So if you are representing the same molecule in a Fisher projection, the Newman projection, we can see that A and B, the angle between the A and B is 180 degree. So here the dihedral angle is 180 degree. I hope that you understood the concept of the dihedral angle. Now we are moving into the different conformations of the ethane. And here in the Newman representation, front carbon atom is represented in a dot and the back carbon atom is represented in a circle. So I have the front carbon atom is stationary and I am going to rotate the back carbon atom. So if you are rotating, the position of both the hydrogen, which is shown in red color, is changes. So in the first conformation, the both hydrogen are just behind to each other, so the dihedral angle is 0 degree. If you are rotating the molecule by 60 degree, that is front carbon is stationary, the back carbon atom is rotated by the 60 degree in the clockwise direction. That means rotating the back carbon atom in the side of the right hand side, we can see the second conformation, and this conformation is known as the staggered, in which both the hydrogen atom is apart by the 60 degree angle. And this conformation is also known as the gauge form, that we will discuss in the later. And if you are rotating another 60 degree, so the position of the hydrogen atom is again rotated by 60. So we will get the third conformation. So the angle between the red color hydrogen is 120. So if you are again rotating the 60 degree again, the total angle of rotation is 180, and see the position of the red colored hydrogen, the angle between the red colored hydrogen is 180. And if you are again rotating the 60 degree, the total angle of rotation is 240, And if you are again rotating 60, we will get 300 degree dihedral angle. Total rotation is 300 degree, but angle of dihedral angle is only 60 degree because the two hydrogen atom are separated by only 60 degree apart. Okay. Hope you understand the concept. In the first conformation, both the red hydrogen atom is just behind to each other. So the dihedral angle is 0 degree. The rotation is also 0 degree. If you are rotating the 60 degree, the rotation, angle of rotation is 60 degree and dihedral angle is also 60 degree. If you are rotating 120 degree, the angle of rotation is 120 degree. Angle of the dihedral angle is also 180 degree. And for 180, the angle of rotation and dihedral angle also same. But if you are rotating the 240 degree, angle of rotation is 240 but dihedral angle is 120. And if you are in the case of 300 degree rotation, the angle of rotation is 300 but dihedral angle is only 60 degree. If you are rotating again 60 degree, we will get the same molecule of the first one. So dihedral angle is 0 degree, angle of rotation is 360. Now I think it is clear. Now next title is the torsion strain. We have three different type of the strain in the conformation while we are drawing the conformation. This is the three conformation. First is the torsion strain, second one is the angular strain, the third one is the steric strain. So torsion strain means it is the if the front carbon atom, is just behind the other atom. That means if it is exist in a eclipsed form, the electron which is present in the one atom is just behind the other. So that is why the electron will repel each other. See here, this is the representation of a molecule in which the two chlorine atom is just behind the other. So the electron which is present in the front chlorine atom will repel with the electrons of the other chlorine atom. So this repulsion is known as the torsional strain. This arises due to the atoms are very much close to each other in space and their electron cloud repel each other. Now we are moving into the steric strain. The steric strain means it arises due to the bulkiness of the group which is attached to the sigma bond. So see here we can see that the two methyl group are just behind each other. So there exists a torsion strain. Similarly, the torsion strain is existing in the case of the hydrogen. But in the case of methane, one more strain is existing, that is the steric strain, which arises due to the bulkiness of the methyl group. If the two bulky group are come close to each other, naturally there is a little space for occupying that molecule. So the strain which arises due to the bulkiness of the group is known as the steric strain. Next is the angular strain. So the angular strain arises due to the dihedral angle, difference in dihedral angle. We have discussed the dihedral angle before, and for this molecule from the structure 1 we can see that the hydrogen atoms are 60 degree apart. So the dihedral angle is 60. So that's why the sigma bond which is present, the electron which is present in the sigma bond CH and CC and CH bond will repel each other. So the repulsion is existing when these bonds are just behind each other. So in the structure 1 we can see that the electron which is present in the sigma bond are 60 degree apart. So the repulsion is very least. Whereas in the case of the structure 2, we can see that the electron which is present in the sigma bond of the front CH bond is just behind the electrons of the sigma bond of the back side. So the electron which is present in the sigma bond will repel each other. So that's why the angular strain is very high in the structure 2. If you are connecting the dihedral angle, in the case of 1, the dihedral angle is 60. and whereas in the case of the 2, dihedral angle is only 0. So from that we can conclude that as the dihedral angle increases, the angular strain is decreases. Okay, that means the repulsion between the sigma electron decreases. Here, the electron present in the sigma bond repel each other. That is the definition of the angular strain. And greater the dihedral angle, smaller would be the angular strain. I hope that the concept of the dihedral angle and angular strain, torsion strain and steric strain is clear for you. Thank you.